Hi everyone, I'm Stephen and welcome to Audio Nautica. So far on the channel, my most popular video has been the repair of this Quad 405-2, which had a dead channel. In that video, I kind of showed you how to refurbish one of these as well at the same time, but not really. So as you can see, I've got another Quad 405-2, and so what I'm going to do in this video is take you through fully how to refurbish one of these wonderful amplifiers. But just before I dive into this, can I please encourage you, if you haven't already, please subscribe to my channel. It really helps me so much in making this kind of content. I'm also on Instagram and I have a Patreon, so those are various ways that you can really support me in being able to make more of this content. Thank you so much. Okay, so if we just have a quick look at this unit, we can see that this one has the DIN input. It doesn't have RCA, so most probably I will add RCAs into this unit. You can get an adapter cable that you can buy on eBay or Amazon. It will just plug into here and give you a couple of RCAs flying out, but I think it's a bit nicer if we can put RCAs in as well. We can see that there's something inside of here. I'm not sure whether it's a wasp's nest or just what that is, but yeah, it's mud. So it looks like it's an animal has made nests in those, so that's going to need to be fixed up. We do have our voltage selection and so on. So that's what our rear panel looks like at the moment. Now this unit was in an organ, so it doesn't have the feet with it. I do have some replacement feet. You can see some screws have been drilled here, which is where it was mounted into the organ. So anyway, if we get the lid off this thing, so getting the lid off is very easy. It's just these two screws here. And that just slides back like so, and the lid is off. Actually, before I do anything else, I'm just going to take this bottom panel off, because these burrs sticking out from these holes and these screws will scratch up my static mat. As you'll see, as we take these bits and pieces off, we can actually take essentially the entire enclosure off from around the entire amplifier. There we go, there's another one of those sheets that's glued on. But the entire amplifier is just built around the chassis and the front panel. So these end plates will come off in a tick as well. Yeah, this way. This way. Yeah. Okay, so no, this one's longer. There's the three screws. Wow, that screw's longer as well. And same other one. There we are. So that's that one out as well. So you can see the amplifier itself is still completely intact electrically. But just look at that, isn't that gorgeous, the way that that's built around the chassis. Now we can access everything. So if we needed to buzz out things on these boards, and as you'll see when we begin refurbishing this properly, these boards, it's just 4 screws. The board comes out, done. So now that everything's nice and accessible, I'm just going to have a closer inspection, bit of a cleanup, and I'll report back when that's done. Okay guys, I've had a really good look inside of this. This looks really, really nice and tidy. So just a few basic things that I've done is check all the fuses, that none of them are blown, but also check the values, because you don't want to make assumptions. So these are 4 amp, and they are 4 amp. However, I found that the main fuse is supposed to be 2.5 amp. It had a 3 amp in there, so not a huge difference, but it should still be the correct value. So I've got a fuse of the correct value here, and I'm just going to fit that now. So we now know that it has, all the fuses are good and they are all the correct value. Okay, so I have no idea when the last time this unit was turned on is, and neither do I know whether it's supposed to be working or not. So I've got two things here. I've got my dim bulb tester, which will basically catch a dead short, but I'm also going to bring it up slowly on the variac. So this will give us the kind of like the most amount of protection. Okay, there we are. That should be about, it's about 240 there. Minus 40 on that one. Plus 40 volts. Minus 40 volts. I can't remember what it's supposed to be, but probably something like that. I've now got mains connected directly. As a sanity check, it's going to check the outputs for DC. Yeah, that's showing minus 5 volts DC on that channel. And that's showing minus 2 volts on that channel. Neither of those is correct. So that is not right. So that does indicate that this amplifier is certainly in need of refurbishment / repair. Now, often you do see these kinds of things for sale on eBay and various places. People selling them in what they call original condition, as if original condition is, a good thing. If you were buying a second-hand car, I don't think you'd want to buy a second-hand car that had never been serviced. And I certainly don't think that you want to buy a 40-year-old amplifier. That's what this is, that has not been serviced. So, in my opinion, if you were to buy an amplifier like this in original condition, well, it may be working when you buy it, but there's a good chance it won't be for long. Next step is I'm going to take these two amplifier boards out so that we can just more closely inspect them and access them, and begin this refurbishment procedure. So just before I begin the refurbishment procedure, obviously there's various opinions out there as to what you can and should do to these units. Now, I certainly don't claim to be an expert in quad 405s, but I did do a fair bit of research into what other people were doing, and I figured that this is a good balance in terms of using modern components, in terms of hopefully giving reliable service life for a good period of time, without going completely overboard. Some other people do more things, sure. Is there value to those things? Perhaps. I'm not saying that there's not, but this is just what I think is a good balance in terms of doing this. So I'll take you completely through my procedure for refurbishing this unit. I'm also going to make a bill of materials available as to what all of the components are, and I'll be putting that bill of materials on my Patreon, making it available for anyone who becomes a patron of my channel, just as a way of thanking you for supporting me and getting this content out there. Okay, so for our next step we need to take out these amplifier boards. So we can see that these just have these quick connect spade terminals on here. So this is the input. And that's the output, was the one that was closest to us, and the other two is the supply. So we've just got these 4 screws. Let's move this over a bit further so you can see, guys. Sorry about that. Now there's a couple of rubber plugs in the back of the unit. If I took those out, they line up perfectly with these screws. But as you can see, I don't actually need to do that. And besides, we're going to use those holes to put our RCAs in. So they will not be there when we're finished. Okay. So there we are. So we can see there are our finals, 1983 date code. So yeah, 39 years old this thing is. These can run pretty hot too. And heat, of course, does tend to dry out electrolytics. So at some point we'll test these STCs. I'm not going to replace them unless I absolutely have to. I haven't actually purchased replacements for those. I have purchased all the other parts, they're ready to go. But I suspect they probably won't need to be replaced. But I have provided in the bill of materials what I would recommend that you can use. I did replace them in the other unit that I did the repair on, but in the end I think I decided that they didn't actually need to be replaced, but I'd already purchased them, so I put them in. But I have kept the electrolytics that I pulled out of the other unit, so honestly, if these ones were no good, that's what I'd put in, is the original ones out of the other unit, because they were fine. Nothing wrong with them at all. And I think so often you do tend to find that in these kind of amplifiers. It's not so much the big main filter capacitors that fail. I mean, of course they can, but usually it tends to be smaller electrolytic capacitors. So that one's loose, but of course we've got to do our quick connects. Just have to unplug these. So yeah, you can see on the back of the silk screen, it tells us out, minus, plus. So red is plus, black is minus. That's signal out, and this is signal in. And it's pretty obvious the one that's shield is ground, and the other one is signal. This thermal compound is still looking at like it's in pretty good condition. Of course we're going to change it, but that is encouraging to see that it's not all dried out. Okay, so that's the other unit. So Yeah, this looks like it's in original condition. So it's these 1, 2, 3, 4. These are the ones that really tend to fail. So what we'll be doing is we'll be replacing these 1, 2, 3, 4. We'll also be replacing this one and this one. And also we've got here our op amp. So we can replace this with a modern low noise equivalent just to give us a little bit of a lift in performance. Hopefully there won't be anything else that needs to be done on this unit. So as you can see, there are no adjustments. There are no trim pots. This thing is designed, I mean, there's not even a bias adjustment. You read the manual, there's no bias adjustments, there's no DC offset adjustments. So yeah, it certainly makes adjusting them easy because you don't have to do it. But yeah, both of these are faulty, and I would suspect that these brown capacitors are probably the problem. Okay, so I've cleaned off the thermal paste off the chassis and also off the amplifier modules. So that means we won't make too much of a mess. So when I get to refurbishing these modules, I'm going to pull out the power transistors and the drivers because there's thermal paste under there. I'm going to get rid of all of that and replace it with some nice sill pads. And also means that while we have these units out, certainly the finals at least anyway, we can test those on the transistor tester, just make sure that they're looking okay. However, one other little test that is rather important is these capacitors. So I'll just see if we can get these wires out without making too much of a mess. Yeah, it came out easily. They just poked through the holes. Oops, there we go. Oh yeah. Lovely looms in this one. Okay, so now you can pull out capacitor tester and we can test these. So they're meant to be 10,000 mic. Yep. Yep, so they read good for capacitance. I think that that ESR is fine. The only way to know for sure what it's supposed to be is to find the data sheets for these 40-year-old capacitors, which you'd have to be pretty lucky to find. But I'm happy with that ESR. Yep, so those units will be staying in there. Okay, so I've reinstated the terminals on these capacitors. Before I dive into the circuit boards, I want to do everything relating to the chassis. So I'm just going to, this is our bridge rectifier, so I'm just going to remove that because I want to see some thermal compound to the chassis. I can't actually see any evidence of any thermal compound on this one. but I think there should be. Yeah, there isn't. So perhaps it's not actually necessary, but my recollection from the other one that I repaired was that there was thermal compound on it. You can see just here, see this whisker here? So obviously it's been like that since manufacture, so I'm just going to cut that off. So yeah, it certainly won't hurt to add a little bit of thermal compounds. So as I mentioned earlier, this unit only has this DIN input for its line ins. So we want to have RCAs, will just make our life a whole lot easier. Okay, so I've got two little RCA connectors here. I haven't listed these on the bill of materials. These just came from my local electronics store, JCar. Pretty common thing. So just need to pop out these two little plugs, because this is where these are going to go. Okay guys, so I'm not going to be able to do this on camera because this is going to be really fiddly. There's a couple of approaches that one could take. Now, the easiest thing to do in terms of getting this going would be simply to desolder these two feeds and bring them over here. That would be really easy. I'm very tempted to do that. The only reason that I'm not is that if you were to pair this with one of the quad preamps, then you would connect it to the quad preamp through this DIN connector, because this is what this is designed to go with, is with a quad preamp. Now, I don't have a quad preamp and I don't intend to get one, so I will be using the RCAs, but in my mind it would be a bit of a shame to decommission this port. Now, if this all ends in tears, then that's what I will end up doing. But at the moment, my plan is to just simply strap over something like so. I may have to adjust the lengths on this. This cable is really not the best for this. This is really too thick. I want something more like this. You know, the length, you know, we're talking about 2 centimeters and 4 centimeters in terms of cable lengths. So you certainly don't need, you know, this is intended for patch cables, and it's just kind of a bit too thick to work with, but it's what I've got. So anyway, I'm going to give this a go, see how I get on. Because I can't really access the back of this connector, I'm going to have to take it out of the panel and solder the harness onto the back of it, then just see how I go with lengths. So I'll report back once I've finished that. So this is now installed. We can have a look at the back and see that I've got them strapped over from the original DIN connector, strapped over to these new RCAs. So as I mentioned, this cable is really too thick. So while I was at JCar, I picked up some of this stuff. This is much better to use. It's about the same size as what's in there already. But as I've got this done with the larger cable, I'm just going to leave it for now. I don't expect there'll be any problems. And also, while I was at JCar, I picked up some of these insulated RCAs, just in case at some point I decide that I want to have the earth insulated from the chassis. But for the moment, I suspect this is probably what we will end up doing. Okay, so I mentioned that this unit did not have any feet, so I have got some feet. And the bottom panel does have some threaded inserts, which are for the feet to screw to. So I can tell you that the screw size for those threaded inserts is M4. I've got M4 by 10s. I'd go with an M4 by 8. I just happen to have these M4s. I wasn't sure what size these threads were, so I got a bit lucky in that, yes, it is M4, but I have 10mm screws, and that's just a little bit long, so we'll see whether that's going to cause me any problems. So we'll just put these on. Yeah, what I'd be a little bit worried about is whether it might foul on anything with the thread sticking up through the bottom of the case. So we need to do a little test fit. And yeah, if they don't fit, then I'll have to get myself some M4 by 8s. Okay guys, going to make a start now on these PCBs. So I'm going to do both boards at the same time, because I think it's going to help me to stay sane, to kind of like do the same component twice, if you know what I mean, rather than doing all one board and then doing all the second board. So let's see how we go here. Lovely overlay markings just make it really easy to tell what's what, thankfully. Now that I've got this one out, so I mentioned that these tend to be problematic, these. So we'll measure this one, see what it comes up as. Oh, well, that's rather disappointing. Totally dead. Open circuit low capacitance. Well, there you go. Yep, well, so far we have a 100% failure rate on those. So we'll put in our replacement. So this is C10, which is 47 mic 40 volt, and plus is okay, so double check, that is plus, correct. Oops. Turn the soldering iron on. Okay, just want the board nice, the cap nice and flush on the board. There we go. When I pressed it up with my finger underneath, I could just feel it drop into place, which is always nice. There we go. Lovely. Now let's do the same on the other board. See what this one's like. one's dead as well. Well, that's rather disappointing. I'll try the new one that I'm about to put in. So we still have a 100% failure rate on these brown capacitors, and I'm sure I did mention earlier on that they are notorious for failing, which, again, repeating what I said earlier on, is why, in my opinion, an original one of these things is a bad proposition. That's better. So these are actually for C18 and C19, so that's C19 there, C18 should be this one over here, yeah, there he is. So I guess while we're at this, we might as well pull them both out. Okay, that's C18, C19, pull him out. Let's test these, see if there's any life left in them. No, that one's dead as well. Let's try this one. Uh-oh, we found one that's not completely dead. Well, that's encouraging. But it's supposed to be 47 mic. It's interesting, it's reading high. See if we can compare to our shiny new capacitors. That's more like it. Alright, let's put these ones into this board. I didn't push them down flush on the board because the lead spacing is not quite the same, so they won't actually sit flush. Right. Okay, now the other board. Lovely land patterns. Just make it so easy to get these desoldered. Unfortunately on this one the leads are not bent too far over. Okay, let's see if there's any life in these. I'm not kind of holding too much promise, I don't think. No, that one's dead. Dead. Yeah, look at that, hey? So C19 positive to the top. Looking nice. Okay, just one of these horrid brown things left to come out now. Now this one is actually a bipolar. Bit of a trap for young players. When I refurbished the last one, I didn't buy a bipolar because I didn't realise that it was bipolar. Till I went to put it in and thought to myself, why can't I find the plus symbol? Because there isn't a plus symbol. My recollection is that this capacitor is something to do with the protection circuit. Basically, this does not have a conventional protection circuit as such, like, you know, there's no relays on the output or anything. But basically this capacitor, if there's DC on the output, this capacitor will effectively charge up. And there's a triac, I believe, that will reduce the output power. So theoretically it winds down the power if it detects DC on the output. So it's a little bit unconventional. I'm not sure that I'd really want to be relying on it to save my speakers. So that's why I'll be using this with protection circuit. Alright, let's just get this guy out and being a little bit problematic. There we go. Just a dagger solder stuck on the end of the pin. Okay, so as I mentioned, this guy is supposed to be bipolar. I'll slide around everywhere, see if I care. Yeah, this one's actually okay. Which is probably not, well, no, it's not okay because the ESR is terrible. But the capacitance is actually correct, which is more than can be said for any of the other ones, but yeah, the ESR is way too high. So I take it back, it's not okay. So let's pull the one out of the other board. That one's out. See if this end's any good. Well, it probably would have functioned for its application, but yeah, it's definitely on the way out as well. So essentially what that means is that out of these brown capacitors, we didn't find a single one that was actually any good. So stick some replacements in for those guys. So as I mentioned, these are bipolar. So there we go. 1, 2, 3, 4 replaced. So there's only two more capacitors I'm going to replace, and that's these two. 100 mic 10 volt. And this guy's 100 mic 6.3 volt. See a huge difference in size. The only difference is 6.3 volt and 10 volt. So I'm just going to replace them with the same capacitor. And I've got these lovely Nichicon muses that I'm going to put in, which actually are quite a bit bigger, but these are quite important capacitors. You know, these aren't power supply capacitors, so I wanted to use basically the best that I could get, more or less, to go in there. So let's pull these out and get them changed over. So these are bipolar as well. Let's see if this one's got any life left in it. I'll be not surprised if it has. 100.16. Yeah, it's not too bad. Let's just compare it to what we're going to put in there. Yeah, comparable. Again, I'm not surprised, but we're going to put these new parts in. Now this one is polarized. Obviously the muse it's going in isn't. See how this reads. Let's try again. That one's dead. Yep, dead. High ESR, low capacitance. So that's not good at all. So I just need to pull them out of the other board. Let's just see how these meter. I expect this one will probably meter okay. Yeah, that's the bipolar one. But then this one, I suspect this one is probably going to be, yep, dead. So of the 6 capacitors we pulled out of each board, 5 of them were essentially dead. So fit these gorgeous Nichicon muses. Okay, that's that one. Okay. So that's the capacitors dealt with. Next step will be to replace this op amp. So I'm just going to see how I go with braid on this rather than the sucker. See how this is feeling. Oh, yep, it's totally loose. That's good. Out. So there's our old original TL071, I think it is, CP. So I'm going to replace that with a nice modern IC. Modern op amp, that is. And I'm also going to socket it. Now I'm using a nice machine pin socket. You certainly do not want to use those horrible spring clip things that you see. So pin 1. The legs on my socket are slightly bent. This is not good. It's better. So pin 1 is there. I've just put a little bit of solder through pin 1 because I need to take this in, because when I turn it upside down it's just going to fall out because of the taller components. So I'm holding it with my finger. Tip for young players, make sure that your finger is not touching the pin that you're going to reheat. There we go. Okay, it's just tacked in for now. I'm going to take the other one out now from the other board, because I think it's going to be easier probably to solder this in using the conical tip rather than the chisel tip. So and I'll keep using this thin braid and see if that continues to prove more successful than the thick braid. I'm just going to confirm this orientation. Yep, pin 1 is there as shown. Okay, that's out. So once again, just a little bit of solder here on pin 1. Replace the solder that got sucked away here. That's better. Okay. So same trick. Oops, there we go. Right, I'm just going to change over to the conical tip. Flux these up a bit. Okay, I'm just going to do one of these boards at a time because I'm going to end up with too many bits floating around otherwise. So, first step is that we need to desolder the pins on these transistors. Both devices are the same, but we do want to put them back where they came from. That's always good engineering practice. Even if things are the same, put them back where they came from. So that I can fulfill my own rhetoric, I should make the piles like so I know what goes where. Now, you want to so, see if there's any juice in my transistor tester. There is. Okay, test clip fixed. So yeah, gain reads as 25, which does sound kind of low without having checked what it's supposed to be. But we'll have a look at this other one. Yeah, gain 127. Okay, so I'm just going to pull out these pre-driver transistors as well, because I do want to check them, and I'm also going to put some nice sill pads underneath them. So I'll just add wait. Let's give these a little test. BJT, PNP, gain 104. Sounds encouraging. Let's see what the other one looks like. Okay, 151. I think that's fine. If it was way low, I'd be worried, but it's not way low. Okay guys, so the next stage is I've cleaned off all of that old thermal paste off this aluminium bracket, which doubles as our heatsink and our earth connection. And also I've cleaned it off the back of these driver transistors. So I'm going to reinstall these in a tick. But just before I do that, I just again need to point out, so you'll see that the tab of these is electrically connected, and obviously the case on the finals is also electrically connected. And you can't have those shorting together. So there are these little, obviously this is connected, but there are these little insulation sleeves in the mounting holes. So it's important to make sure that they are still there, that they haven't disintegrated or anything like that. Otherwise, we'll have a big problem. So, I'm going to replace the thermal compound with these lovely silicon heat transfer pads, which also double as our electrical installation as well. So yeah, lovely, we get 2 parts in one. Thermal transfer paste is replaced by these, and the mica insulating washer is replaced by these. Okay, now those are mounted, we should verify that they are not electrically connected to the chassis. That one is not, and that one is not. So that's what we want to see. So now that these are mounted, I can just solder these back in. So, I've gone as far as I can with that board now because I need to replace these final transistors. So I'm just going to set this one aside out of the way, and we'll do the same on this one, because if I find that one of these is the same, low gain or dead, then I'm going to need to get a replacement for that. So I just want to make sure that I have all the replacements that I need. Okay, so once again, first step is going to be to desolder these transistors. Just a little bit of flux will make that easier. I'm really not sure that the solder pump was achieving very much. It's getting a little bit out, but we'll just see how we go. Just trying to wick the whole lot. It is a fair bit of solder, but I suspect it's probably less mucking about just to do it this way. Alrighty. It's looking promising. Often they'll just be stuck on just one side of the pad, and you can usually just push it off with the iron. Let's see what these ones look like. I think those are loose. Yeah. Yep, that's the one. You really do need to desolder them first, because if you don't, you'll risk damaging the pads due to the strain on the legs by doing this. Right, let's see how these ones are looking. $88. It's a bit lower than what the other one was. I mean, I need to look at the spec just to see what it's meant to be. See what this one is. $79. Okay, well they're both comparable. Why don't I go and look up the spec right now so that I can tell you what it's supposed to be? Okay guys, I could not find a data sheet for the original transistors, but I did check the data for the replacement transistors that are commonly used. Most people seem to use an MJ15003, and according to the data, its gain is a minimum of 25. So even the lowest gain on one of these RCAs was, I think it was 45 from memory. But there is a fairly wild divergence in gain of these four devices, and they don't need to be matched as such. They should certainly be the same type of device in the same board. I am leaning towards replacing them because the generally consensus seems to be that you can get a better boost of performance in terms of using a more modern transistor. And I did find a local source where the price is not too bad, $9.95 Australian, that's probably excluding GST, whereas DigiKey, they're $15 Australian each, plus freight. On top of that, I'm pretty sure that price is excluding GST as well. So, yeah, that's a much more reasonable price. It's just from a place just down the road for me, so I can get them fairly easily. So I'm leaning towards doing that, and I'll need to make my decision tomorrow, but I suspect that I'll feel more comfortable with replacement transistors in this unit. This is the much nicer unit out of the two units that I have, so I want it to be a nice unit essentially. Okay, so as I did on the other board, I'm just taking out these driver transistors now because we do need to check those. Well, we don't need to check them, we should check them, but I do need to clean off this thermal paste because I am going to put sill pads in as we did on the other board already. So again, it's the same trick, just take them out. I've already desoldered them. There we are. Take this one out. And throw these micro pads away because we're not going to be using those. And I didn't actually do it on camera. I'm not going to do the whole thing of, because cleaning is not very exciting on camera, is it now? But cleaning up this thermal paste, I've tried a few different ways of doing this. With the heatsink, which I also need to do, I just use paper towel for that. Just wipe it off with a paper towel. This one, the paper towel's a little bit too fiddly, so I'm just using Q-tips. Now, Isopropanol will kind of dissolve this stuff, but it does make a bit of a mess as well. And I just found that, you know, just physically removing it like so just seems to do a really nice job. If there's places that are a little bit needing a bit more persuasion, then sure, use the ISO on those. So basically what I do just to do a final clean on this one is just spray a little bit of ISO onto the end of my Q-tip, and then just like so. Just gets rid of these little bits and pieces around the side. So that one's cleaned up, and I'll do the other one off camera because I know it's boring. Okay, so they're all cleaned up. I've cleaned up the heatsink as well. So now just checking these transistors. Gain 132, that sounds pretty good to me. And I check this other one. $118 looks pretty good to me. So I'm happy with these driver transistors. So those ones can go back in as well. Okay, so now we're going to reinstall these driver transistors. Going with some nice sill pads underneath them. So now I just need to resolder these. So I picked up 4 new MJ15003 transistors. Now the ones that I got down the road, they're MOSPEC brand, but I checked the specs, they seem fairly comparable to the onsemi ones, which are the ones that I've used before. However, when I tested these on the transistor tester, I get really weird results for the gain. So the minimum gain according to the data sheet is supposed to be 20, yet one of these it tests like 11, which is just really bizarre. So I just don't really feel comfortable using these. As I mentioned, the minimum gain is 20, and all of these original transistors, whilst there is a fair bit of variation in their current gain, they are all within spec. So I'm going to use the original transistors. I don't think the gain is especially critical because of the topology that these amplifiers use. So we will put these back in, and as you can see, I'm going to use these sill pads, which just means it will end up with a whole lot less mess. So again, we have to be careful that we make sure that these little insulation sleeves are intact on the case. But I'm quite confident, famous last words I know, but I'm quite confident that once we put this unit back together, it should hopefully work quite nicely. Once these transistors are in, we've done everything that we need to do electrically. We just need to reassemble the unit. So probably should just check that we don't have any shorts to case before I put the next one in. Yeah, that's good. The great thing about these sill pads is just no mess, no mucking around with that thermal paste. Now we will have to use some thermal paste when we reattach these boards to the front panel, which is also the heatsink. But yeah, it's nice not to have to worry about it here. I need to clean this up yet, but I'll reassemble the other one first. Yeah. Oh, one important thing to do. There we go. Perfect. Okay. Yeah, good. So we just need to deflux this board a bit now. That was no good. It was pointing the wrong way, so I tried to deflux myself. A bit more light needed. This is a light that tends to flicker. Hopefully it's not too bad. But I do need to be able to see what I'm doing. Some of this flux is from when it was made. Not my flux. Okay. It's looking nice. Not sure if you can see that, but see how this joint here on R7, it just looks really, you know, it probably isn't dry, but it just looks really cold. It doesn't have a nice conical mount of solder like the others do. And so when you see a joint like that, You always get a little bit suspicious. This being problematic, isn't it? That's better. There we go. So the other one should hopefully have, it hasn't quite dried off yet, but it's working on it. But yeah, it looks a lot better. So while that's drying off, we can fit our new op amps. Presuming that I can get the bag open. Right. So you really just need to give the legs a little bit of a squeeze like that. There is a special tool that you can get that will do that, but I don't have it, surprisingly enough. Okay, so pin 1 goes that way. Now it needs more of a squeeze. There we go. In. Okay, same deal on this one. In. Beautiful. So theoretically, these two are ready to go now. So I just need to put some thermal compound onto these heat sinks and mount them in. Okay, so now we just need to put some thermal compound on this guy. How to do it without making too much of a mess. Rightio. So this one goes up this way. How are we going to do this? I might try doing this and just see if I can drop it in the hole. Like that. we need to put these back on. Now, it does actually say on the silk screen which is which as well. So this one is plus. This one is minus. This is the output. And this one is signal earth. And that one is signal. Okay. That is that channel. All good to go. Okay, so I've added the thermal paste onto this board just like the other one. Now this one fits into the chassis around the other way, just so again the bottom side of the board faces outward, which makes it really easy to meter things out. One last thing to do just before we power this thing up is to plug this second board in. So that's plus there. This is minus. That's the output. That is signal ground. And that one is signal. Okay. So there we are. That's hooked up. That's hooked up. Capacitors are reinstated. This is all good to go, not shorting to anything. New fuse. So hopefully that's everything. So I'll just put a power plug into it. Now, I do have the dim bulb tester in there just in case anything catastrophic happens. It seems encouraging to me. So, take our dim bulb tester away. So power back on. So a couple of things that I want to check. Firstly, check DC output, DC on the outputs. About 100 millivolts. And that one. So 1.8 millivolts, sorry, what was this one? Sorry, yeah. Yeah, it's nothing. Let's just see what we've got up here. 53 volts. That's more like it. Sorry, minus 53. That one's plus 53. It was low when I read it. It was about, remember, it was about 40 volts, so it was low. Not too surprising with all those dead capacitors. Now, I also just want to check Just reach around the corner. These are the Zener diodes for the op amp. So there are 15 volt Zener diodes, so that one's minus 14. And that one's 15. I think that's okay. And I just need to disconnect the power while I move this. Because I'm not going to be able to get to this side. Okay. Power back on. It's minus 15. That one's plus 14. Oops. $14.5. I think that's okay. So I'll just get this swung around again and we'll get a signal into it. Right, we're all hooked up, speakers are connected. Now I have got them connected through my external speaker protector kit. So I did already check for DC voltage, but there's a couple of ways that I want to do this. Either I could use dummy loads or some kind of protection on my speakers. So listen to that. So I've got my iPad function generator hooked up. Just need to make sure it's actually coming out of both speakers. Yeah, it's coming out of that one. Make sure it's coming out of this one. Yes, it is coming out of that one. So we have a stereo sine wave. I guess I could have just done this, couldn't I? Oh, it doesn't help that much. Yeah, I could do that. So, and that's really, really encouraging. I'm just going to test it now with a little bit of music. For copyright reasons, I can't show you that, but I'll just do a little bit more testing with music. And then I'll put the covers on, but this is looking really, really encouraging that our Quad 405-2 is playing nicely after this refurbishment. Okay guys, just got it hooked up to the scope. As you can see, we've got a lovely clean sine wave on both channels. Done a fair bit of testing with some music and with the scope, and that looks really, really encouraging. So I'll put the covers back on this thing now. Alright, so let's just put the covers back on now. They do say which one is which, so this one is R, so I've got it facing towards me, so this is actually the right side here. Well, it's actually really cool. It's sort of, there's a lip on this back panel and it catches on that lip, but it's probably just going to be a bit easier if I do this. Okay. Working. I hadn't checked that yet because it was always facing the other way. And we just come back to our signal generator. There we go. And I'll just have a quick check. I can hear any hum or anything. It's the tiniest little bit of hum. A little bit of hiss as well. But I don't think that's going to be a problem. So there we are. One Quad 405-2 that has been fully refurbished. I'll just show you, I've still got them sitting down the back here. The parts that we replaced. So that's for, it'll be for the right channel actually, and this will be for the left channel. So there we are. Those are the parts that we replaced, and these are the parts that, in my opinion, need to be replaced in pretty much every single Quad 405-2. Definitely these brown capacitors, you remember that they were all dead. This was dead. These measured okay, but we replaced it with that gorgeous Nichicon Muse. And we also took out these old op amps. We put in a machine pin socket and put in a nice new low noise TI op amp. So hopefully with a Quad 405-2 that doesn't have anything catastrophically wrong with it, that's all that needs to be replaced. And this one, as you notice, it was not working because of these dead components. But this was all that needed to be changed. We didn't need to change anything else. The main filter capacitors were fine. The final transistors were fine in the end. So that's all really, really good. So I really hope that you've enjoyed this video, which has been a full walkthrough on how to refurbish a Quad 405-2. If you liked it, please give me a thumbs up and subscribe to my channel. And I look forward to seeing you on the next video. Bye for now.